Hi guys, Dr. Callahan here. Welcome to week 4, Monday for AP Calculus AB Semester 1. These are 3 questions for this morning. The first one is find the limit as x approaches 3 for x squared minus 9 over x cubed minus 27. Number 2, textbooks. Do you like them? Explain your likes and dislikes. How would you use them in other classes? Give me one example. And number 3, what is the limit? How do you find the limit? And list the 3 different types of method that we use to find limits. All right, let's go ahead and take a look at question number 1. So looking at this one right here, your limit is as x approaches 3. You always want to try direct substitution, in which case if I do that, that's going to give me a 27 minus a 27 will result in a 0 in the denominator, which will be undefined. So strategically, we need to think about other things, other methods with algebra that we can do to perhaps cancel something in the denominator so it doesn't result in a 0. So if I take a look at my numerator, I know that this is a special factorization. What times what gives me a negative 9, but when I add it together, gives me a 0x, which is technically what's in the middle. So I do a negative 3 and positive 3. On the bottom, I know this is a factorization of cubes. So I know that a minus b and I should say that it's a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And just to make sure that that is correct, I'm going to go ahead and check that. So factorization of cubes. Yes, that is correct. All right, just want to make sure. Okay, so then looking at this right here, I can do x cubed minus 3 cubed. So you know that a equals x and b equals 3. So if I were to go ahead and rewrite this in the denominator, I will have a minus b, which will be an x minus 3 times a squared, which is x cubed, or excuse me, x squared, plus a times b, so that's 3x, plus b squared, and that's 9. If I look directly from my numerator and denominator, I can see that I have x minus 3 that I can go ahead and cancel, which will leave me with a limit as x approaches 3 with an x plus 3 in the numerator and x squared plus 3x plus 9. Now at this point, you can use direct substitution and not result in undefined. So I'm just going to go ahead and plug in the 3. So I have a 9 plus a 9 plus a 9, which is going to give me a 6 over 27. I can go ahead and reduce that down to a 3 or 2. 6 divided by 3 is a 2 and a 9. And that is my answer. Question number 3. Here are the 3 things that you can use for finding your limits. One is a table, okay? And that's problematic sometimes because you do have some errors when you're plugging into a TI-84 calculator. And then also some parts of the test on your AP exam does not allow to use the calculator, so that's out. So that's a negative. You can go ahead and graph it, but you're going to have a TI-84 calculator, and again, sometimes you can't use it. Next one is algebraically. So this is what we just went over for the last example. And the strategies that we have are like the conjugate, make sure you FOIL, factor, and then cancel. So this is going to be the breakdown for your grades. I've had used this system since 2018, but your math Excel is going to be worth 25%. Your final exam in this class is 15%. Your meeting standard, which is going to be your quizzes and whatnot, is 35%. Algebra IO is 5%. Practicing all the things you do in class is 15%, and then your warm-up is 5%. So this essentially is a breakdown of your grade. Keep in mind that your homework is always on a math Excel. It's due on Sunday by 11 p.m. Wednesday is your assessment. It's always going to be on either AP College Board, Math Excel, or it could be in paper format. If you're going to be absent, make sure you look at the videos on the YouTube channel. And from now on, you guys will have a grade check every Wednesday. If I see you, if I don't see you, I'll give it to you on Thursday or maybe even Tuesday, and I'll print them in class. Okay, so let's take a look at the breakdown. Today, we're going to go over 3 different examples in class. We're going to be evaluating limits with a table graph and with algebra, specifically just algebra, because we're already done with tables and graphs. And then I'm going to have you guys do a poster rotation, although you'll probably do the poster rotation with practice problems over the YouTube video, and you'll probably do it by yourself, since we have to socially distance with each other. So now let's take a look at your guided notes. So this is the first page of week 4 Monday. Second page, third page, and the fourth page. And this is the 3 examples we're going to go over in class. It was brought to my attention that your guided notes is missing some pages from the print shop. So you have all your notes up to week 3 Tuesday, and then it skips, or week 3 Thursday, and then it skips over to week 4 Thursday. So we're essentially missing like a week worth of pages. So if you're going to be in my class in person, I will give you guys those handouts separately. If you're not, you can just go ahead and do this on a separate piece of paper. That's not a problem. All right, you guys, let's go ahead and take a look at question number 1. So this is one of those really nasty fractions that we have here. If I use direct substitution, unfortunately, it doesn't help me because it does give me a result in a 0 in the denominator, which is undefined. So strategically, I'm going to go ahead and focus just on the numerator and see if maybe I can do something with that so I can have one fraction instead of having 2 separate fractions. So let's go back to the 3rd grade. We're going to have common denominators. I'm going to multiply the first fraction by 4 because I know my common denominator is going to be a 4x. Do the same thing with the second fraction. So then I have 4 over 4x minus x over 4x. So that's going to be 4 minus x over 4x. So I did combine the 2 fractions on top into a 1. And then this is going to be divided by, don't forget your denominator on the bottom, x minus 4. Now, I don't like the way this looks, so I'm going to rewrite it. So I have 4 minus x over 4x. Instead of doing a division, going back to 3rd grade, you're going to flip it over to a reciprocal. So I'm going to do a multiplication, and that's going to be 1 over x minus 4. As I'm taking a look at the numerator and denominator, I realize that 4 minus x is very, very similar to x minus 4. The only difference is that if I can maybe perhaps flip the signs, so I make that into a -4 and that into a positive x. So I can actually do that if I factor out a -1. If I factor out a -1, I will have a -4 plus x, or essentially -1 x minus 4. And I'm not doing anything illegal. Everything here is arithmetically sound. So then once I have that, you keep the -1 right here, but I'm going to cross out the x minus 4. So then in my numerator, I'm going to result with a -1 over the denominator, which is a 4x. And guess what? I'm able to alleviate the problem that I had initially with direct substitution. And so now if I use direct substitution as x approaches a 4, I will just have a -1 over 4 times 4, which means my answer is a -1 over 16. And that is my final answer. Okay, problem number 2. As I'm looking at this, I told you guys before that another strategy that we use is to use the conjugate, and let's just try direct substitution. If I were to do that, I will have square root of 9, which is going to be a 3, but then a 3 minus a 3 will result in a 0, which will be undefined. So I can use direct substitution. So my strategy here is going to be using conjugates. So let's go ahead and multiply the conjugate, which is x plus 9 plus 3 on the top, and the square root of x plus 9 plus 3 on the bottom. So if I go ahead and do that, I will have in the numerator x times the square root of x plus 9 plus 3. On the bottom, you guessed that you would have to FOIL it. So let's go ahead and do that. FOIL. Okay, so first, square root of x plus 9 times the same square root of x plus 9. The square root and the square root is going to cancel, and the content inside the square root is just going to be x plus 9. And then you're going to do the outer. So positive 3 times the square root of x plus 9 is going to be a positive 3x plus 9. I kind of want to go back to the first in case you're not sure how that worked. So when I have something like this, square root of x plus 9 times the square root of x plus 9, that essentially is the same thing as square root of x plus 9 squared. And you know how to get rid of a square root is with a square. So that square root and that square cancels, and everything inside that square root is taken out. So that's how I got the x plus 9, in case you were not sure. Figure I probably should explain that a little bit better. Then you're going to go ahead and do the inner, which is going to be a negative 3 times the square root of x plus 9. And then lastly, you have a negative 3 times a positive 3, which is going to be a negative 9. And notice that your outer and inner cancels because you have a positive and a negative, but then also your positive 9 and a negative 9 cancels. So this entire thing just becomes x, which is totally fine by me because my x in the numerator and denominator just cancels. And then I'm left with the square root of x plus 9 plus 3 with a limit as x approaches 0. So then I have a 0 plus 9 plus 3, which is a 3 plus 3, and that is going to give me a 6. All right, next one, let's take a look at problem number 3. Direct substitution, you can just see it. It's going to result in a 0, so I would have to do something algebraically with this. So this one's a little bit different because you don't have a conjugate in the denominator. I have a conjugate in the numerator. So I'm just going to go ahead and multiply the conjugate on the top and the bottom, because you can multiply anything with 1. And when I do that, let's go ahead and FOIL the numerator. First is going to be square root of x plus 2 times the square root of x plus 2. Like I said before in the last example, when you have a square, the square and the square root cancels, and then whatever you have inside the square root is just by itself. So in this case, it's x plus 2. Then you do the outer, which is going to be a positive 3 times the square root of x plus 2. And they do the inner, which is going to be a negative 3 times the square root of x plus 2. And then you do the last, which is a negative 9. And I think you guys can kind of see the pattern here. Outer and inner has a positive and a negative, so they cancel. Here, the 2 and the negative 9 gives me a negative 7. So I will have a x minus 7 on top. Or excuse me, yeah, x minus 7 on top. And then if I take a look at the denominator, I have x minus 7. You don't want to FOIL this one in the denominator because if you look, you have the x plus 7 on top. That's what I want to get, that's kind of what I want to have to get rid of the denominator, which is making everything undefined. So you don't want to FOIL this on the bottom. You just kind of want to keep it as is. So x plus 2, and I should probably make that a little bit smaller, plus 3. And I'm going to go ahead and cancel my numerator and denominator. So my numerator is now a 1, and have a 1 over square root of x plus 2 plus 3 with a limit as x approaches 7. So if I use direct substitution now, I know I will not have it undefined. So I have 1 over square root of 9 plus 3, which is 1 over 3 plus 3, which is 1 over 6. And that is your answer. Okay, so now I'm going to have you guys go ahead and practice a little bit. Now with the poster rotation, you can go ahead and show your work in your guided notes, and you're going to be turning over to this page right here for the poster rotation. And I'm just going to show you guys the practice problems on the posters, and then you can go ahead and work them out on your own. So this is station 1, station 2, station 3, station 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Or actually, just 12, just kidding. All right, you guys, that pretty much concludes everything for today. I hope you guys have a good day. We'll see you guys next